Morning, everyone. Today we have a new objective. We're going to solve equations that have no solutions or many solutions. And you can see we have our first problem here. 5x minus 15 equals 5 times the quantity x minus 3. And we're just going to approach this the same way we've approached any equation up till this point. We simplify both sides, and then we're going to try and collect all the variables to one side, all the constants to the other side. So I'm going to start with the distributive property. This is still just 5x minus 15 equals 5 times x is 5x, 5 times 3, negative 15. And I might then choose to, let's say, just add 15 to both sides. Maybe I decide to move all the constant terms to the right side. And I might notice that something weird happens. Negative 15 plus 15 is 0. Negative 15 plus 15 is also 0. So I get 5x's on the left side of the equation is equal to 5x's on the right side of the equation. Now I might also try to move all my x terms to, say, the left side. And I would take 5x's away here. And whatever I do to the right side, I must do to the left side to maintain balance. And so I get this kind of weird, this is also going to add to 0. I get this answer that just says 0 equals 0, which of course is true. But I might go back up here and realize that 5 times a number, if that's equal to 5 times that same number, this is always going to be true. In other words, I could substitute a 1 in for x and get something like 5 times 1 is equal to 5 times 1, or maybe 5 times 2 is equal to 5 times 2, or 5 times 100 billion is equal to 100 billion. So essentially, x could be any real number. And there's a symbol for that. So you could either write all real numbers, or you could write this symbol that's just a capital R with an additional stem on it. So what you're looking for is if all of the variable terms cancel out and they add to 0, we're left with something true. We could have even seen that maybe as early as up here. 5 times a number minus 15. Of course, that's going to be the same thing as 5 times that same number minus 15. Once you realize that's going to happen, all real numbers. Okay, let's look at one more here. And I might change colors here real quick. And this one's a little different, but again, we're going to approach it the same way. Distribute, combine all like terms. We're going to move all of our x terms to one side of the equation and all of our constants to the right. So I'm going to start with 2x. Okay, 3 times x. Okay. And we do have some like terms to combine here. We have 2x's and 3x's, which is 5x's plus 3 is equal to 5x's plus 4. Okay, so this one's a little different. I'm going to maybe start by moving all my constant terms to the right side. In other words, we'll just subtract 3, take 3 away from each side. And then these ones, of course, cancel. We get 5x is equal to 5x plus 1. Now I'll move all my variable terms to the left side. I want to undo 5x. We're going to just take away 5x's from each side. And notice that something kind of weird happens here as well. 5x minus 5x is 0. 5x minus 5x is 0. We get 0 equals 1, which is not true. This is a false statement. And maybe to explain this, I might go back up to, say, this step right here. 5 times a number, add 3. This says it's equal to 5 times that same number, add 4. These are never going to be in balance. I could substitute, in other words, I could substitute a 1 in for x, and I get 5 plus 3. That's never going to be equal to 5 plus 4, okay? In other words, if I take the 5x terms away from each side, I get something false. There's no number for x I could ever plug in to ever make 0 equal to 1. That's never going to happen. 0 is never going to be equal to 1. In this case, I write no. There's no solution to this equation. All right, have a great day, folks. Enjoy.